Good day to Dr. Emilia. We are Group 5 from Acoustic and Lightning Section 2. Today we will be present for our project titled Assessment and Improvement Proposal of Acoustic and Lightning Performance in DEWAN KULIAH 8. So the team member, including Lim Wei Sheng, me, Ang Yijia, Wong Dong Han, Isaac Akma, and also Valentine. I will start the presentation with the introduction. Our study area for this project is DEWAN KULIAH 8, located at Block 1, UDHM, which used for lectures, presentation, and academic discussion. The physical characteristic of this DEWAN KULIAH 8 including it having concrete tile flooring, painted brick walls, and also flush ceiling panels. So below table has shown the element in DEWAN KULIAH 8. So it having a central entrance as shown in the left hand side of the pictures, and also a wall mounted projector and PA system at the right hand side of the pictures. So it also having multiple aluminum window with partial coverage of the curtain. In terms of the mechanical system, it having 3 ceiling fans and 4 wall-mounted split unit air conditioners. For lighting, it having 12 ceiling light pairs including 8 LED light and 4 fluorescent lamp. So if referring to the left hand side at the last row of the picture, so it is a lighting layout in DEWAN KULIAH 8. To evaluate the acoustic and lighting performance in DEWAN KULIAH 8, several guidelines has been referred. So first is ISO 3382-1-2, which stated that the reverberation time for the classroom should be in between 1 to 1.5 seconds, and the noise rating should be in between 25 to 30 in order to ensure the speech clarity. And second, we refer to MS 1525-2019. The background noise for a classroom should be less than or equal to 35 decibel A-rated in order to ensure the speech intelligibility in a noisy environment. For lighting, we refer to MS 1525-2019, which stated that the illuminance for the classroom should be in between 300 to 500 lux at the desk level to ensure the sufficient lighting for the learning task. The uniformity ratio also stated that should be more than or equal to 0.7 to ensure the light in across the room have been evenly distributed.
My name is Wong Dong Han with metric number F21012. So now I will explain the procedure and the setup to get the data. So this is the information of study area. The location is at B1DK8. And the date of recorded the data is on 4th of June 2025. So the room dimension is length with 19.37 meter, width is 7.13 meter, and the height is 2.92 meter. While the room features is 70 student chairs with a group stack student chair at the back, and one whiteboard, wall mount PA system, projector screen, hanging projector, solid wood table, and one executive chair for the lecturer. 4 aircon, 3 ceiling fan, 1 electric panel, 2 chalkboards, and 1 foam board. So the room is to doesn't have the acoustic panels, and the operation of mechanical ventilations is using during the data record we just stay open for one air conditioner operates while recording the background noise and reverberation time, and the lighting is 8 T8 LED ceiling light, and 4 of it is T8 fluorescent ceiling light. The window is outward opening casement windows, and that day is a sunny day without direct sunlight. So so these are the apparatus that we are using for record the reverberation time, background noise, and also the illuminance level. So acoustic, we're using a sound level meter, reverberator, sound source, calibrator, and amplifier. And the lighting, we're using the lux meter, and other is the laser meter, tripod, and calibrator. So these apparatus, we borrow it from the lab of acoustic in FCAP. So this is the procedure for acoustic measurements for background noise and reverberation time. So I explain the reverberation time first lah. So basically the same things, calibrate the sound level meter using calibrator, mount the microphone on a tripod at 1.5 meter height, then connect it to the vibrator, place the sound source at a separate location, also 1.5 meter from the ground, activate the electrical appliance in the room, activate the sound source, then leave the room immediately because it is quite noisy. But you can set it uh what is that? Escape time. The escape time maybe like 10 seconds before it start the sound source lah. So that you got enough of time to leaving the room. So after leaving the room, the sound source play, and then the sound limiter, sound level meter will record the sound. We just allow it 15 to 20 seconds after the sound source emit an impulsive sound, then record the vibration time for each frequency. And then there got a lot of recording point. We just repeat it, and then we get the vibration time and record it down. So to the background noise is more simpler than the vibration time because background noise is only we record it using the sound limiter. We put it and then we record, but just make sure the one who record is only one person. It's only one person in the room, and then the one is record it, and then just don't do any movement because every single movement will affect the data lot. So just play, record, and then stop it. Just like that. Just don't do any movement lah. You just this is the most of the important part to get an accurate data for the background noise for this project. So for the illuminance level is more more through the lighting system lah. So we just ensure all lighting is turned on and operating as it normally would during typical use during lecture time. So allow light to stabilize for 5 to 10 minutes before measurements and positions the lux meter sensor at 0.75 meter. Is like around the table, the sitting positions of the students above the floor, representing typical student desk height lah. So ensure the sensor is facing directly upward towards the ceilings and maintain a consistent grid pattern while recording. Wait for the lux meter to stabilize as at each point and record each lux reading. So we just put it and stay the stabilized and then record it down. Put it, record it down, put it, record it down to every grid in the room. So this is the 3D sketch of the DEWAN KULIAH 8. I use SketchUp for drawing all these sketching one by one, part one by one for every chair, and then the aircon, fan. As you can see that the fan is on on the ceiling, and the ceiling light also on the ceiling lah. And aircon also I draw it one by one, part by part. So there got six of it lah, which is the isometric view, plan view, front view. As you can see that this is the wall. I just open it and then you can go and see this front view and then side view, edge view, and the last one is the rear view.
Now let's go for the background noise calculation. As you can see, I've divided the DEWAN KULIAH 8 into 6 recording areas, and based on the formula given in the screen, I've calculated their average sound pressure level in the tables. By picking some certain frequencies, my total average sound pressure level is 44 decibels, which is higher than the 35 decibel that is stated in the Malaysian standard. This will increase the sound reverberation, making it more difficult for students to hear clearly what lecturers say. And below is the background noise against frequency graph. As the frequency increase, the background noise decrease. According to ISO, the NC rating for a lecture hall is between 25 to 35. However, our result obtained that the NC rating is close to the 45. This will reduce the acoustic comfort and reduce the speech intelligibility for the student and also the lecturer. Next is the reverberation time. I have calculated all the average reverberation time based on their frequency in the table. And same as the background noise, I picking some certain frequency to calculate the total average reverberation time. My answer is 1.43 seconds. And the time for the 60 decibels to decay is 4.29 seconds, which is much more higher than the ISO stated, this will greatly reduce the speech clarity and the student might have difficult to hear and struggle to understand what lecturers say. Below is the reverberation time against frequency graph. As the frequency increase, the reverberation time decrease. For the illumination level of DKA, the lowest illumination level is 150 lux. Meanwhile, for the highest is 390 lux. You can see the lighting contour plot. The yellowest part is the brightest part in the room. It is because it's very close to the door or the window. I sum all the illumination level in the room and divided by 36 recording area. My average illumination level of DKA is 258.8 lux, which is less than the Malaysian standard stated 300 until 500 for the lecture hall. This will cause the student to struggle while reading or taking notes during the class. And for the uniformity ratio, again, is 0.58, which is also less than the Malaysia standard 0.7. This will cause the visual discomfort to the student, especially in the darker corners.
For the proposal for acoustic improvement, first we need to compare between the measured value and the recommended standard. The first parameter is reverberation time, RT60, where the measured value is 4.29 seconds and the recommended standard is 1 until 1.5 second. The reference is from ISO 3382-1. For the background noise level, the measured value is 44 decibel and the recommended standard is equal or lower than 35 decibel. The reference is Malaysian Standard 1525 2019. And for the noise criterion NC, the measured value is NC 45 and the recommended standard is NC 25 to NC 30 and the reference is from ISO 3382-1. These findings indicate that DK8 has a highly reverberant sound field and elevated noise level, leading to poor acoustic comfort and compromised speech clarity for students, particularly those seated at the back. For the proposed acoustic treatments, focusing on reverberation control, first is the installation of acoustic panel, where the material is the fabric wrapped fiberglass panel. It will cover 60 meters square, which is 30% of the net wall area. And the placement is rear and side wall at seated head height. And the new reverberation time is 0.94 seconds. Next is the ceiling baffle, where the material is suspended fiberglass baffle, where the NRC is 0.8 and coverage is 20 baffles is 1 meter square. And the new reverberation time is 0.82 seconds. And next is heavy curtains for windows. The material is Velodrap, where the NRC is 0.7 and it will cover full 25 meter square window area. And the new reverberation time is 0.7. For the proposed acoustic treatment, focusing on background noise reduction, first is HVAC noise mitigation, where we installed acoustic enclosures around air conditioning units. The ST5, and we also replaced ceiling fans with low noise model, where the value is equal or lower than 25 decibel. And the expected reduction for background noise, it will lower to 29 decibel. And next, for the door and window sill, where we apply acoustic gasket and automatic door sweep, and also replace the hollow core doors with solid core doors, where the STC value is 35, and the expected reduction for the noise intrusion is 35 decibel. For the expected outcome, the current value for reverberation time is 4.29 second, and after the some changes, it lower to 0.71 seconds. The noise level reduced from 44 to 29. The noise criterion reduced from NC 45 to NC 30. And for the speech intelligibility, it changed from poor to excellent, where the STI is higher or equal to 0.6. And as we can see, the post-treatment value achieve the standard from this 4 parameter.
Hello, these are the current situation of the lighting in DK8 lecture hall. This lecture hall employs a hybrid lighting system featuring 12 pairs of symmetrically arranged ceiling fixtures with louvered reflectors for artificial illumination. The abundant natural light enters through numerous aluminum frame windows, contributing to energy efficiency. However, these large windows can cause glares on screens and whiteboard, requiring the use of curtains for daylight and glare control. The measured illuminance level average is 258.8 LUX with the minimum of 150 LUX, but the uniformity ratio of approximately 0.58 is below the recommended standard for educational environments, indicating an uneven light distribution. Next, based on the comparison between the measured value and the recommended standard table, the DK8 lecture hall lighting provided an average illuminance of 258.8 LUX, which is below the MS 1525 standard. Though it boasts excellent energy efficiency with a low LPD of 6.10 watt per meter square. Despite its energy performance, the system's uniformity is poor at 0.58, which below the 0.7 threshold, potentially impacting visual comfort and learning in the lecture hall. Lastly, these are the proposed components change in the DK8 lecture hall for lighting system. To improve lighting, we propose replacing existing features with a high lumen neutral to cool white LED luminaires to promote concentration. Energy efficiency will be boosted by photo sensors near windows, automatically dimming or switching off light as the natural light allows. Lastly, the automated blinds will further optimize daylight control for various activities and lecture needs. That is all from me. Thank you.
To sum up everything, the measured value in DEWAN KULIAH 8 for the illuminance level is 258.8 lux, which do not reach to the standard requirement. So the proposed improvement for it is by replacing the current lightning with a high luminance LED light, and also install the sensor-based control can help to enhance the lightning efficiency. So for the sound pressure level, DEWAN KULIAH 8 achieved a 44 decibel. So in order to meet to the standard requirement, the installation of acoustic enclosure around the HVAC and also replace the fan with a low noise model, which less than 25 decibel can help to improve it. For the noise criterion, so the DEWAN KULIAH 8 having a 45 value, so in order to make it to the standard requirement, the installation of door or window sills and also replace the hollow door with a solid core can help to reduce to the desired value. For the reverberation time in DEWAN KULIAH 8, it is 4.29 seconds. So installations such as acoustic panels, ceiling buffer, and also replace with velar curtains can help to improve it. And last is uniformity ratio, which obtains 0.58 for DEWAN KULIAH 8 should be in more than or equal to 0.7. So improve it by install the reflector and also the optic design for the lightning layout in DEWAN KULIAH 8 in order to achieve to the desired value. So that's all the presentation from group 5. Thank you for listening.